In this lesson, we're going to continue to solve linear systems. In the past, we learned how to solve linear systems 3 different ways, and our solution was always an ordered pair. In this lesson, you're going to notice that we're going to get a different answer. We're not going to get necessarily an ordered pair. Sometimes we will, but other times you're going to get many solutions or no solutions. This lesson is going to be similar to when we were solving equations and inequalities, and we got many solutions and no solutions. So I'm going to put a linear system on the board, and I'm going to use all 3 methods to solve this to show you what it's going to look like if you get many or no solutions. So let's start with this linear system. 2x minus 3y equals 6, and 2x minus 3y equals -4. We're going to start by graphing this. To graph this system, we need to change our equations into slope-intercept form. We need to solve for y. So let's start with the first equation. I'm going to bring 2x over by subtracting. These are not like terms, so you can't combine them. I'm going to put -2x first and then 6. You can also have 6 minus 2x. On the left side, I have a -3y. You have to divide both sides by a -3. Make sure you divide everything on the right side by a -3. So we get y equals negative divided by a negative is a positive. 6 divided by a -3 is a -2. I'm going to solve the other equation for y. Bring 2x over first, and these are not like terms, so I cannot combine them. So I get y equals 2/3 x plus 4/3. Okay, so we get our solution when or where these 2 lines intersect when we graph. -2, that's our y-intercept, and our slope tells us to go up 2 to the right 3. Up 2 to the right 3. Use my straight edge. Okay. Now I'm going to graph the other equation. Our y-intercept is 4/3. I'm going to turn that into a mixed number, 1 and 1/3. 1 and 1/3. And then our slope tells us to go up 2 to the right 3. Up 2 to the right 3. Or down 2 to the left 3. Again, I'm using my straight edge. Okay. In the past, our solution is wherever the 2 lines intersect. Well, these are parallel lines, so they're never going to intersect. If they're never going to intersect, you're not going to have a solution. So whenever you get parallel lines, your answer is going to be no solution. You can't get an ordered pair because they do not intersect. Your answer will be no solution. Okay. But some of you don't like the graphing method. So what does it look like if you use substitution or elimination? So let's try these equations again. This time I'm using substitution. The equations were 2x minus 3y equals 6, and then 2x minus 3y equals a -4. All right, substitution is where you need to solve for a variable. None of these variables do not have a coefficient. They all have coefficients, so I'm just going to pick, I don't know, this 2. So I'm going to solve for 2, or this x. I'm going to solve for this x. Sorry, not 2. So I want this x to be by itself. I'm going to bring 3y to the other side. So I get 2x equals 6 plus 3y. Divide both sides by 2. 6 divided by 2 is 3. 3 divided by 2 can't do it, so I'm going to leave the fraction. Okay. Because none of these have, because all of these have a coefficient, this is not the most, the easiest, or this is not the method you should be choosing, because it's not the easiest because you have to work with fractions, but you'll still get an answer. So this x value needs to go into the other equation. 2 times 3 plus 3 minus 3, well that's 0y, so the y's cancel out. I'm left with 6 equals a negative 4. Okay. When your variables cancel out and you get a false statement, your answer is going to be no solutions. So when you get a false statement, your answer is no solutions. Again, this only happens when your variables are gone. If your variables do not cancel out, you would do what we previously learned. One more time with this method. This time I'm going to use elimination. 2x minus 3y equals 6. And 2x minus 3y equals a negative 4. Okay. In elimination, we need to have one set of opposite coefficients. So I'm going to work with 2 and 2. I need to make 1, 2 negative. I'm just going to make the second one negative. So the first equation stays the same. The second equation, I get a negative 2x, a positive 3y, and a positive 4. Because I have opposite coefficients here, I can solve. These cancel out. Negative 3 plus 3, well, they also cancel out. So on the left side, I have 0. On the right side, I have 10. Again, when you get a false statement, your answer is going to be no solutions. Okay. On your homework, are they going to make you solve all 3 ways? Absolutely not. Okay, you get to pick one of your favorite method and then just solve it once. Let's try one more of these. Let's try 4x minus 2y equals 8 and y equals 2x minus 4. Okay, I'm going to do all 3 methods again with this equation. Make sure you write them all down. Let's start with graphing. The graphing method tells us that we need to solve for slope-intercept form. So I'm going to take this first equation, and I'm going to solve for y. So I'm going to bring 4x over first. We cannot combine the things on the right side. On the left side, I have a negative 2y. Negative 4 divided by negative 2 is 2. 8 divided by negative 2 is negative 4. Lucky us, the second equation is already in slope-intercept form. Maybe you're noticing something right now. Maybe not. Okay, so the red equation has a y-intercept of negative 4. And a slope of up 2 to the right 1. Now the green equation, start at negative 4, up 2 to the right 1. Okay. Again, your answer is normally where the 2 lines intersect. Well, this does more than intersecting. These 2 lines coincide, or mean they're stacked on top of each other. That means every single ordered pair on this set of lines, any ordered pair on this equation, is a solution. So when they're stacked on top of each other, or when they are the same line, your answer is going to be many solutions. But what does that look like if you use substitution or elimination? Let's take a look. We have 4x minus 2y equals 8, and y equals 2x minus 4. Well, this is a nice problem for substitution because y is already solved for. I'm going to plug it into the other equation. 4x minus 2 times this quantity equals 8. distributive property, I'm going to distribute this negative 2. So negative 2 times 2 is a negative 4x. Negative 2 times a negative 8 is a positive 8. Okay, combine these like terms. 4 minus 4 is 0. The x's cancel out. Notice we get a true statement. When you get a true statement and there are no variables, your answer is going to be many solutions. Okay. Last one right here. We're going to use elimination. 4x minus 2y equals 8, and then y equals 2x minus 4. Before we can use elimination, both equations need to be in the same form. I'm going to change this bottom equation and put it into standard form. So I'm going to bring this 2x over to the other side. So it changes into negative 2x plus y equals negative 4. The top equation did not change. Okay, step 2 is to make sure you have a pair of opposite coefficients. I'm going to work with the x's again. I need to have 4 and negative 4. So the bottom equation, I'm going to multiply by 2. So I get negative 2x plus 2y equals negative 8. The top equation, well, not negative 2x. 2 times negative 2 is negative 4. The top equation did not change. Now that I have a set of opposite coefficients, I can add. 4 minus 4, well that's 0x. Negative 2 plus 2, well that's 0y. On the right side, 8 minus 8, well that's also 0. Here again, I have a true statement. Whenever you get a true statement, your answer is going to be many solutions. Okay, so here's what I want you to do. I want you to look for a pattern between these two problems. On your homework, they're going to have you do two things. They're going to give you a linear system like this. You can choose what method you want to do and solve to see how many answers you're going to have. You're going to have one solution, you're going to have no solutions, or you're going to have many solutions. But at the end of your homework, the other half, they want you to look at the equations, and without solving, they want you to decide if it has one solution, many solutions, or no solutions. I want you to look at the top problem, the second problem, and then problems we've had in the past where we've gotten one solution, and see if you can find a pattern and figure out how many solutions they have without solving.